Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we will solve another question from Leetcode. So let's get started. Yes, so today we have this problems. Best time to buy and sell stock 5. So that is a kind of like one of the most asked problems in any interview perspective, and it is one of indeed your recursions or your dynamic, less than dynamic programmings, but more on like your recursion fundamentals is going to be tested for sure. So that is indeed a like very good problems to solve. Like here I have to say your indeed like problem solving is like recursive function state management is going to be built on the different levels. So I must have to suggest to everyone to solve this kind of variant problems for at least once. So what is given in the problem, that is very standard, like DP on stocks. So here you can see you are given an integer array prices. So prices is the price of the stocks in dollars on the ith day. Very straightforward. And an integer k. You are allowed to make at most k transactions, where each transactions can be either of the following: a normal transactions, that means you can buy on day I and then sell later on j, so where I less than j. Expected your profit is price of j minus price of I, so that much profit you can make. You have buy at ith day and sum of some later day, that is higher of my I, sum of that jth day you can sell it, so your profit is prices of j minus prices of I. Short selling transactions, sell on day I, you can sell on ith day and then buy later on j, and buy later on day j, where I less than equals to I less than j. So your profit is prices of I, so that is you are doing first sellings then buying. So on second transactions, on first transaction, normal transaction, you are buying, then you are selling some of the later day. But here you're first selling it out, then on some later day you have to buy, So that is the problems. So that is a short selling transactions, which is kind of a new or this is actually the points where this problems is going to be on max difficulty level. Although it is tagged as a medium, but I personally feels like it is the indeed hard problems on DP of stocks that can be possible. That is indeed on hard difficulty on DP of stocks that can be possible. Now note that you must complete each transactions before starting another, which is expected. Like if your transaction is ongoing, then you can't like start another transactions. Additionally, you can't buy or sell on the same day. That is another constant. You can't buy and sell on the same day. That is like very straight English and self-explanatory also. Or buying back as a part of the previous transactions. So that means you can't do two consecutive buys. So if you start a buy, so if then your transaction is in progress. When it is going to be ended, when you done a selling, then only your transactions is in terminal state. If your transaction is ongoing, so if you start with a buy, then you have to sell it. Or if you have start with a sell, you have to buy it. To make the transactions to be neutralized. Now return the maximum profit, return the maximum total profit you can earn by making at most k transactions. So you are allowed to do at most k transactions. With that, what is the maximum profit you can achieve? So an example test case you can see. So we are starting with we are buying at price 1 and selling at price 7. So we are buying with profit 1 and we are buying with price $1 and selling with price $9. So here you can see a normal transactions, buy at day 0 with $1 and sell it day 2 with $9. So the profit here is 9 minus 1 is 8. Now you can do a second kind of transactions, that is of sell by transactions or short selling transactions. At here you can sell it at 8 and you can buy it at 2. So 8 minus 2, the profit is 6. So here 6, here 8 plus 6 is 14. 8 plus 6 is 14. So here you can see $8 and $2. So that is of $8 is the sell price, $2 is the buy price. So short selling transactions is making these problems on a different difficulty levels. So you can do a normal transactions, you can do either buy sell, and short selling transactions you can do sell buy. So that is the new. On this example test case, here you can see k is 3. You can achieve a profit of 36. So which is the steps? The steps is mentioned here. 12, 19, 12, this 12 and this 19. 12 and 19 you can do buy sell, normal transaction, short selling transactions 19, 8, then this 19, then 8. Short selling transactions, right? Then normal transactions 119, right? This 19. Yes. So you are done with your 3 transactions and you have make a profit of 36, right? So that is the maximum you can achieve. Now I am assuming your recursions and your DP DP or recursions on DP kind of things is very strong, and you should be like at very first go should predict. We need to just write the recursive functions optimally. We just have to write the recursive functions optimally. So rather than like going here and there, we will start writing directly our recursive code, because this is a very straightforward, clear hints. You have choices. So I'm not going to start from very basics, very brute. So it is for sure sort of choice problems. We can see the choices. We can either start buying. We can if we have the liberty to do a buy sales, we can either start with starting a transactions from buy, then on some successive days we will sell, or we can start selling it, or in successive days we will do the buy. So we definitely have blindly, we can see the choices. So why DP, why recursions, I'm not going to explain that, because that is you have to be set, your mindset should be set. You should be able to point whether it is a recursion on DP, when actually we have to use recursions or DP on or when it is not. So you should be able to point it. There is a choice state is associated for this particular problem. So I'm skipping that intuitions part, right? Now we can start on it. So what we have at, so how actually our recursive code should looks like. So I'm directly writing the recursive functions. If it is allowing me to do so. I think it's again started off crying. Yes, can you able to allow me to write, please? So I have a def functions, def of my helper, that is my very lucky charms of any recursion. So I will definitely have an index. So this is going from 0 to n. And I have what I need two more variables. How many variables you more needed? I definitely have a k. Apart from k, what actually I need? For other problems, you can use a single booleans that is actually pointing either a transaction is going on. But on other problems, we just have to take care of either your transaction is ongoing. So these booleans you just need. But here, if your transaction is ongoing, if yes, then you have to know either it is a buy type transactions, that means you have started with a buy, or it is a sell type transactions, that means you have started with a sell. That you have to know. So that's the reasons we need two booleans rather than a single booleans. We need a buy. So that means our buy is true. So that means we have the liberty to buy. Sell means we have the liberty to sell, right? And another one is k, right? So that's the reasons we need not a single booleans, we need two booleans. This will go till n. This has two values, zeros and ones. This has two values, zeros and ones. This has of size k. So n for our case is as big as 10 raised to the power 5. This is of 2. This k is 10 cube by 2. As an very old case. So it is, if you can multiply, so that is your complexity, that is your time complexity. This 2 gets cancelled. So 2 into 10 raised to the power 6. So that is your time complexity is bound to going to be happen if you write a dynamic programming solutions with it. So DP is what? I know you should know these fundamentals. DP is nothing but your number of changing parameters. You just have to store it in a tables. You just have to store it in some storage locations. You have to initialize some data structure to store it. That's it DP. So your dynamic programming time complexity is nothing but your multiplications of your changing variables maximum size. So the time complexity is bound to be 2 into 10 raised to the power 6 for this particular case. So now let's try to write the pseudocode or the recursive code at least. Now what is the base case of our recursions? If our k is 0, so that means we have done all the transactions. So are we able to make any buy or sales? No, return 0 directly. Else if my I equals to n, so now when I can say I have both buy and sell in place. So that means now when I have at I equals to n at the index, so there can be some partial transactions happening. So maybe I have started with some buy. I have started with some buy, so my buy liability I don't have, so buy is 0. Or maybe I have started with some sell, so my sell liability is 0, but buy we have it. So if that is the case, so that means there is a partial transaction. So either I have started with a buy but not able to sell it, or I have started with a sell but not able to buy it. So on that particular case, we have to return a what do we have to return for this particular example? Is the maximum profit. And to So what is the invalid case then? What is the invalid case? So that means if it is a partial transactions and we reach to the nth, if we are out of bound and we have lying in doing some partial transactions, then on that particular case we can return some illogical value, some invalid value for this particular example. So for maxi, what is the illogical value or invalid value? The mini. What is the range? I can return a minus 10 raised to the power 9 from here. Why minus 10 raised to the power 9? Because you can see our maximum grow limit can be as plus 10 raised to the power 9. So what is the invalid case then? How we can neutralize that? How we can make sure that this particular case you are not going to get your maximized profit, right? Your maximum profits. How you can invalidate this particular recursive calls? By throwing an invalid value. What is the invalid value here? For maximizations, what is the invalid value? Minus 10 raised to the power minus mini minus sys dot max size. You can return minus sys dot max size also, right? You can also return minus sys dot max size, but please make sure that is of minus sys dot max size. You can return minus 10 raised to the power 5 9 or minus sys dot max size. Now what is the valid case? If I have both buy liability and I have both sell liability, so that means complete transactions we have done. So we have done some transactions. So we are not have to use all the case. We can use at most case. Maybe we can use at least one case. So that is also fine. We can use 2 case, 3 case, but less than equals to case. So that means transactions we are liable to do. So on that particular case also we have done some transactions, but we have done complete transactions. So on that case also we are returning 0. So we are at out of bound and we have done some complete transactions. That is a valid case. You can return a 0. Else you are going to return a minus 10 raised to the power 9 or minus sys dot max size. So that is the that is the base. That is your base case. This 2 is the base case. Now we have choices. Right? Now we have choices. Now if we can initialize our result to be some value of 0, now we have choices. Now if our buy is set, now we have 2 choices. If my sale is set or not. I can do a sale also. Or I can write the first case if my sale is 0. So that means I have started with a buy. But I don't have a selling liability. So what is the profit here? So I can only do buy. So buy means my money is going outside. So prices of I. So so when I'm buying, so my money is going out. So how we can neutralize the things? By giving my money from my pocket. So that means prices of I am considering it negative. So buy means negative. So that many amount we are spending. Plus we are going to, for sure we are going to next index to be of I plus 1. Tell me the transitions, guys. We are doing here. What we are doing? We don't have the selling liability. We have the buy liability. So I am doing the buy. So my buy liability becomes 0 and my sell liability we can see it should be sell equals sell only. We can put only sell only here. Right? So here you can see, give me 1 minute, let me just check it out. Sorry, I done a small, I think, mistake here. So when you're buy, so your sell liability is 0. So what actually it means? So that means you have done some selling and now your buy liability is set. So that means you are doing that buy. So that means your transaction is going to be completed. Your transaction is going to be completed, right? If your transaction is going to be completed, so you have your buy and set, both liability is going to be set, because from very next index you have the liberty to do both buy and sell, and your transactions count is going to be decreased by -1. So that is one case, right? So I guess you guys understood this. So we have buy liability set, sale we have already done, and now we just have to do a buy to make a complete transactions. So we did a buy and my buy sell liberty becomes 1 So now from the very next index we can do a buy or sell, whatever we want, because our complete transactions has just ended to the ith index. So I plus 1 index, we have both liberty, and one transaction has done, so it becomes k-1. Else, very straightforward case. We are not doing anything. So whatever the buy, whatever the sell, it can go as it is. It can go as it is, right? That is one case. If I can shorten it out, is it vanish or where it is? So that is one case, right? Else, I have buy liberty and both sell liberty. I have both buy liberty and sell liberty. So use both. So I will first try to buy it. I am buying, right? If I am buying, then my which liability is going? My buy liability is going. So 0, 1. Transaction is happening. Complete transaction is happening. No complete transactions. K should be as it is. Or Or what can I do? What can I do? I can write here only. I can do a selling. I can start with a selling transactions. Prices of I plus helper of I plus 1. Now we are doing selling. My buy liability should be same. Selling liability gone, and K should be as it is. K should be as it is. Or I am not doing anything. I am not doing anything. So I am going to just of the next state I plus 1. My buy liability have at, my sell liability have at, and or maybe I can write buy, sell, whatever it is, and my K should be as it is. K should be as it is, and I have to take the maximum of all of the three. So I should have to take the maximum of all of them, all of the threes. Now this case is very clear, right? So here see guys, actually the recursions is actually the beauty here. Writing the recursions is actually the beauty here. Now on the sell case, now if my buy is not set, so I will check. So I don't have the buy liberty. So on the else block, I have not the sell liberty also. Okay, I don't have sell liberty also. What I can do? I can write a helper of, I should go to the next index to whatever the buy, whatever the sell as it is. I don't have any liberty to do buy sell, right? Else I have the sell liberty. I have the sell liberty. So do a selling. So that means I don't have buy liberty. So that means I have done some buying. Right? I have done some buying. So I am doing a sale. So I'm doing a sale here. I am taking the value. So that means I have done some buying and now I am doing a sale. Transaction is completed. Transactions becomes completed. So I plus 1, I am going to I plus 1 and setting both to be 1, and transactions count becomes K minus 1. So that is one case. Or else I am just going to go to very next index, not changing anyone's. So whatever the buy value, whatever the sell value, and whatever the K value should as it is. Right? Now I think to memorize it very simple. Now you can just push these three keys, I, your buy, your sell, your K, to be your store it, whatever the maximum result you got here, and finally you can return your result. And you should make a call to your helper functions with 0th index. We have buy liberty initially, we have sell liberty initially, and we have K factors this, right? Exactly that things you just have to write to get an AC. Now here before of that, for every DP, write just 2 lines. If my I, buy, sell, K in DP, so return from here itself. Don't make any functions call. So return DP of I, buy, sell, K. Yes, we can return. So yes, that's exactly you have to write. Now we can do a quick iterations of our code. Now here you can see we have start helper I, buy, sell, K. In I have initialized the variables in DP mini. N should be len of prices, DP should be dict, and mini should be my minus 10 raised to the power 9. Now if K is 0, return 0. If I equals to 10, and I have both buy and sell, so that means I have done some complete transactions, so I can return a 0. Else return mini. So that is an invalid recursions calls you have tracking. So that means there are some partial transactions. You have started with buy but not able to sell it. You have started with some sell, not able to buy it. And if this particular key is in your DP, return your DP of this. Otherwise start your result to be 0. Now if you have buy liberty and you don't have sell liberty, so exact functions called result equals to max of minus prices of I. You are doing a buy and you are completing a complete transactions. I plus 1, 1, buy sell, both liberty, and K minus 1, complete transactions. Else helper of I plus 1, buy sell, K. You are not doing anything. Else you have both liberty. You can either do buy, you can either do sell, you either can do nothing. So I am doing buy, minus prices of I, helper of I plus 1, buy liberty gone, sell liberty have at K. Doing sell, prices of I plus 1, buy liberty have at, sell liberty gone, helper of I plus 1, buy sell, K. Not doing anything. If else block, I don't have buy liberty. If I don't have sell liberty also, okay. If I don't have buy liberty, I don't have sell liberty, go to the next index. I can't do anything. Helper of I plus 1, buy sell, K. Else I have sell liberty only. So result of prices of I. So that means I don't have buy liberty and I only have sell liberty and I am doing selling. So that means transaction is going to be completed. Prices of I, helper of I plus 1. So that means complete transactions has completed at ith index. So I plus 1 should have both buy and sell liberty set. Complete transactions done. So K minus 1. Else I am not doing anything. Helper of I plus 1, buy sell, K. Right? Exact same. See guys, code is itself is going to be tail of itself. Now DP of I, buy sell to be K and storing the result and returning the result. Calling your helper functions with 0. Buy liberty on, sell liberty on, K is also to be K. So that is the recursive functions. Now I have tried the iterative version. So iterative versions is exactly the same code. Here you have to initialize your DP to be mini for underscore in range k plus 1, for underscore in range 2, that is of by, that is of cell, and that is of n plus 1. And I am writing the exact same code for I in range n minus 1, for by in range 2, for cell in range 2, for remaining in range k plus 1 if I at n. So what I have to do? See here. So converting a recursive code to iterative. See guys how simple it is. If I is equals to n, so I just have to check. If my by and cell both are set, I have to return 0. Else I have to return mini. So here I have to just store them. If I equals to n, so here bottom up. From bottom we are going up. If I equals to n, so if my by is equals to 1, cell is equals to 1. So then dp of n by cell remaining to be of 0. Else I am storing dp of n by cell to be, I can write it some, why it is gone to next line, not sure why. So here you can store it to be of this I n by cell remaining to be mini. Exact same code. The exact base case we have written here top, we have just have to write it on the iterative. Else we are starting our result to be 0. If we have by liberty, then if we don't have cell liberty, then what we can do? If our remainings is greater than 1, so that because we are fetching some remaining minus 1, some k minus 1, right? Some remaining minus 1. So that's the reason. So there is 2 branching. Every time we have 2 branching. If my remaining has greater than equals to 1, then we have to check something else. Else we have to check something on other side. So if we have the by liberty and we don't have cell liberty, so I am doing a by and I am taking, so that means a complete transaction is happening. So I am going to I plus 1 and I am setting both my by cell to be 1 and my transaction is going to be completed remaining minus 1, right? Else I am not doing anything. Not else, like I can either do this or I am not doing anything. DP of I plus 1 by cell remaining, right? On else block, if remainings, I don't have any transactions at all, so I can't do anything. So remaining is 0, so I don't have any transactions. So DP of I plus 1 by cell remaining, whatever it is, stored it. Else I have 3 options. I can either do what I can do, doing nothing, doing by, doing cell. You can go through on your own, you will get it. Else I don't have by liberty and I don't have cell liberty, so result equals to dp of I plus 1 by cell remaining. I don't have anything to do. Else that exact same code I have written, what I have written here. If I don't have by liberty but I have cell liberty, I am doing selling, transaction is going to be completed, I plus 1, 1, both are going to be set, remaining minus 1, and on other side I am not doing anything, dp of I plus 1 by cell remaining. Else if I don't have to do any transactions at all, else result equals to dp of I plus 1 by cell remaining, and I am storing my dp of I by cell remaining to be result. And finally I am returning whatever the values to the first functions call. Here you can see we are calling our functions to be 0, 1, 1k, and here we are also returning dp of 0, 1k, whatever the value we are returning. So yes guys, that is the iterative functions. Now we can quickly discuss the time complexity. So the time complexity on both the versions is same, that is of big O of 2 into 10 raised to the power 6, 10 raised to the power 6, right? That is the time complexity, exact time complexity. And space complexity also same, big O of 2 into 10 raised to the power 6. That is the exact time complexity also, guys. Yes. And that is the most optimized time and space complexity you can achieve for this particular video for sure. So that is one problem where I see that recursive code is not going to get us an AC. So here you can see like the recursive code that I have written, that is going to get an memory limit exceeded on last example test case, that is of 775 test case first 776 number test case, it is giving us memory limit exceeded. So that is one example case only where I find it, but on most of the cases it will work. So here actually the iterative code is working exactly fine here. So that is the iterative versions that we discussed. So that's the reasons I have just discussed the iterative versions, but on 99.99% case, write your recursive code and it will 100% work for all the cases. It will 100% work for all the cases, only like 0.001% cases. So that is one example case, it is not working, not sure why, but you should be able to write the iterative versions. If you are able to write any recursive version, you should be able to write its corresponding iterative versions for sure. So that's the reasons we have discussed the iterative versions for this particular example test case. Yes, so I guess I have tried my best to explain to you guys, and it is one of the most asked important question on any interview perspective. I will definitely suggest to submit on your own at least once of these particular problems, and if you guys are able to understand till this point, I guess you guys are already doing so. Please do subscribe to our channel, and please share the videos to your friends circle who are also preparing for top product-based company and brushing up their DSS skills. And please turn on the notification so that when we are going to live to our next video, you guys are going to get the notification as soon as possible. So that's it guys, that's it for today. Let's meet tomorrow with another video question. Bye guys, bye.